Something absolutely amazing is taking place on your computer and you probably don't even know it. The internet has run for decades using an addressing scheme called IPv4. So let me show you an example IPv4 address. Now if you look at this address, you'll see that we've got 4 values that go between, well, basically 1 and 254. So there's 4 of these values separated by 3 dots. So when you look at this value, every computer that's actually on the internet must have some kind of IP address. And these IPv4 addresses have worked for decades and they've done a great job. Except for one big problem. We've run out of them. We have literally don't have any more of these IPv4 addresses. So instead, we have a new version of IP coming out called IPv6. Now with the old IPv4, let's get rid of that mess. With the old IPv4, you had a total of 4 billion addresses. And this is amazing because when they originally invented IP addressing, they would say things like, well, you know, we could have up to 12,000 computers on this new thing called the internet one day. So they figured if they had a total of 4 billion addresses, that would be plenty, and they were wrong. So the bottom line is we now live in a world where we are transitioning from IPv4 into the world of IPv6. So instead of having addresses that look like that old IPv4 address, they now look something like this. This is an IPv6 address. An IPv6 address is distinct because first of all, you'll notice that it's going to have 1, 2, 3, 4, 5, 6, 7, 8 groups separated by 7 colons. So this is a physically much more writing there is to do. Now, in terms of the number of addresses we have now, well, it's a lot more than 4 billion, I'll tell you that. So basically take all the air molecules on Earth and divide it by about 7, and that's how many IP addresses we have with IPv6. So hopefully we won't be running out anytime soon. So IPv6 provides some real benefits. Number one, it gives us a greater address space, but it also gets rid of a lot of old-fashioned stuff, and I'll describe those as we get more into IPv6. But before we go too far, what I want to show you is the proper nomenclature for IPv6. So as we take a look at this address, first of all, you'll notice that it's got 8 groups separated by 7 colons, but you'll notice that this is a lot of writing. So there's a shorthand, and I want you to be comfortable with this. So the first thing I want you to be able to do is take a look at this address. Now, what we're going to do is get rid of all the leading zeros. So let's go ahead and write it again, this time without any leading zeros. It's quite a bit shorter now, you see that? So any place we had 4 zeros, it's simply a single 0 now. And instead of having 0001, it's just a 1. So we can make things a lot easier by dumping the leading zeros. Now it can get a little bit cooler than that too. So do you see where we have 3 zeros in a row? What we can do is simply compress all that and simply replace it with a double colon, looking something like this. So when it comes to IPv6 addresses, it's important to remember that we can always write this type of shorthand and make a little bit easier for us to actually write these addresses. Okay, now when we're dealing with IPv6, in the world of IPv4 you only had 1 IP address. In the world of IPv6, that's no longer true. On today's system, you will have an absolute minimum of 2 separate IP addresses. One address is known as the link local address. Now the link local address is distinct because it's always going to start with FE80 followed by 0000, 0000, 0000. The last half of the address is automatically generated by your system itself. So the link local address is automatically created. You boot up a computer that's IPv6 capable, it will have a link local address. The other address is what we call the global unicast address, or simply the internet address. The internet address is brought down from your actual router itself. The router will send out a broadcast that says the first half of your address is something, and then your computer automatically generates the second half. So you're always going to be having 2 addresses. So I've got a Windows system right here that is IPv6 capable. Let's go ahead and take a look at IPv6 and let me show you those addresses. So I'm just going to run ipconfig, and if you take a look here, you'll see number 1, do you see this link local address that starts with FE80, and you'll see the double colon because I've got 3 sets of 4 zeros in there. So this is it's local discussion event. You see where it says %3, that is a Microsoft Windows thing. Please ignore it. Also notice that I still have an IPv4 address, so that's still there. Now, if you take a look here, you're going to see these are my internet or global unicast addresses. Now, notice I have one that says this is my IPv6 address, but you'll also see that those are temporary addresses in there as well. As a security feature, computers will have one main IPv6 address, but they can, and this really depends on the operating system, can spin up temporary addresses. So if they make one quick connection to a web server over here, it'll use that address, or it can make another connection to a FTP server over there and use a different address, or if you're talking on voice over IP, it makes another one. So this is all a security feature, and it really makes IPv6 very secure. The beautiful part about IPv6, especially for the exam, is it's very important that you can recognize an IPv4 address versus an IPv6 address. Also keep in mind with IPv4 you only have one address, and that's where our subnet mask becomes so very, very important. With IPv6 we still have what's kind of like a subnet address, but we really just call it a prefix, which is fixed at what we call WAC 64. So the first half is always going to be right where your prefix is. The nice part about this is that we need a subnet mask in IPv4 to be able to tell if we're making a call on my local area network or if I'm making a long distance call. But with IPv6, the prefix is simply used to allow us to talk to upstream routers to get our data to the places we need it the very, very quickest.